Alright, in as quick a time as we can, we're going to build a not quite so mini hotspot version 2. We need a board. On the board right now is this as yet unsoldered modem chip. I'm going to use the hot air method. I've got my syringe full of solder here. In your kit, you're going to have 4 jumpers. You're going to have 2 2-pin headers, 3 3-pin headers, and 1 6-pin header. And those all go across the top of the board here, with the exception of one of the 2 pins, which goes not quite in the middle of the board next to the where the pick will go. Alright, it's real simple. Alright, so next we're going to do the discrete capacitors and also the PTT switch transistor, and also the, maybe you see that here, the voltage regulator. Alright, next is crystals. I've got 2 different types of crystals here. I've got a slimline crystal and a regular size crystal. I've only got them just to demonstrate that there's 2 different types. Your kit may have 2 of these, or 2 of the other ones, or 1 of each. It doesn't really matter. Just make sure that the frequency of the crystal is put in the right place. This one happens to be 4.9125, which is this one here. That clocks the modem chip at the correct frequency. And this one happens to be the 24 meg one, which clocks the PIC microprocessor. Actually what it does is it makes the PIC operate at the same speed as the USB bus. The USB bus operates at 12 megahertz. So it does a divide by 2, and lo and behold, it's operating at the same speed as the USB bus. That way it's easy for us to communicate up and down the USB bus. Nope, sorry. My goggles are a bit too a bit too big. Alright, and again, give it a haircut. Right, see, crystals. Alright, next up, variable resistors, or pots. They obviously go down here where all these funny square things are with the 3 legs. All the pots are not the same value. One of them, this one here, happens to be a 10K, all the others are 100K. Populate them here, the 100K goes into R34 as per the I'm sorry, try that again. The 10K goes here to R34. The rest of them populate in the rest of the holes. Gently push them in. They'll actually hold themselves. You don't have to bend anything. They're a slight friction fit. There they are. Just check that they're all seated nice. Again, don't have to be, but you know, it's your board. You do want it to look good. Alright, we've just installed 6 perfectly serviceable, nothing wrong with them, pots. Now we're going to break one of them. Okay, there's a pot labelled TX or R36. It's this one here. We're going to cut off the leg right here. Can you see that? This leg I've cut off. Okay, why did I do that? There's a bug on the board. That leg is grounded and it shouldn't be, and that in turn causes there to be little to no transmit audio voltage coming out of it. It sends most of it to ground. So that's the fix. It's to unground the leg, and the way we do that is just to chop the leg off. Alright, we're going to populate the resistors next. There's an awful lot of these, so it'll take us a while. But basically just do them by value, and you can't really go wrong. I'm going to start with 27K, and I'll see you when we're done. Oh, one more thing. The resistors don't go in the usual fashion. They go in upright, which means that you have to bend the leg through 180 degrees, the top leg through 180 degrees. So that you end up with a device like that. That in turn, where does this one go? R14, which of course can't find. Haha, there it is, R14. That will go like that, and it will stand upright on the board like that. There is also a little legend on the board to tell you which side to put the body, so you should be good to go. And that's how that goes. And all the others go there in the same way. Alright, it's time to test it now. We've got our test meter here, and also got the board. You'll note there's no silicon in there yet apart from the modem chip, you're going to need a source of 5 volts. The easiest place to find that is the USB cable on your PC. Alternatively, you could put 12 volts in here on pin 9 on this connector, move this jumper across to the other position, and that will allow the regulator to do its thing, and thus you'll be able to generate 5 volts. Alright, let's get on with it. Plug it in. First thing you'll notice is that this LED should come on. That just tells us that we've got power to the board, nothing other than that. Okay, also check for blue smoke. Got any? No? Good. Didn't put any in the packet, so you can't exactly stick it on the board. Alright, now we're going to have a poke around. Refer to the instructions for this, but it will tell you what pins to search. Ground we need can be found either here on this the shell of this connector, or right here on this pin. And we're going to test, there's a small via between these two blue resistors, and our meter says 5.12 volts. That's good. That's about what we expect. Okay, we should also inspect IC5 pin 8. IC5 is over here. Pin 8 is here. 5.1213 volts. Okay, so that's good. We should also check for 5 volts here also, which is the supply to our DigiCos chip. And finally we want pin 20, I think it's that one. No, that's not, that's half rail, wait a minute. Pin 20, 28, 27, 26, 25, 24, 23, 21, 20. How about that one there, 5.12. Coolies. Alright, so all our voltages are correct, so that means if we plug our chips in, they won't explode. Whether they work, well, that remains to be seen. Okay. Alright, so the last step in construction anyway is to install all the silicon. That is the PIC microprocessor. Okay, there's a little nipple in one end. That denotes that that is the pin 1 end. There's a nipple on the board on the legend, so that would fit in there. It won't go straight in because you know, its pins are flared slightly. Move the board out of the way. Leaning on the desk, just very gently roll it, and that will bend all the pins just slightly inwards, and you can see it's much less flared than it was. Okay, offer it up to the board. With any luck, it should just go, whoops, wait a minute, got mine slightly out of sync, don't do that, it'll bend. There we go, that goes in first time. Keep your finger on it, bend it over, and bend diagonally opposite pins, just slightly, and then that'll hold that in there like that. Okay, so that's the PIC installed. That PIC is pre-programmed by me with the Dutch style bootloader, and so you shouldn't need to reprogram it via the PIC-Kit2 interface, but if you do, well then that's fine, the PIC-Kit2 interface is there. Okay, this next chip, the next biggest one, is the Digital COS chip. It's actually a voltage comparator. And that of course goes in there, faces downwards. Again, nipple on the chip, nipple on the board, spin it over, diagonally opposite pins, bend those back, and that's not going anywhere now. Okay, and finally we've got our dual op amp, handles both the transmit and receive amplification, just to make sure that the audio levels are at a fixed voltage and don't vary. Okay, and again, nipple on the chip, nipple on the board, line those up, drop it in, and bend diagonally opposite pins. Alright, and then you've got to solder it, of course. And final inspection of your work, just to make sure that you've got no solder shorts or splashes or anything like that. I'm good. That's it. That is the finished board. All it needs to happen to it now is that it be set up.